Today we will start module 4 in which the speed control of induction motors are discussed. First of all, we will have a mathematical analysis on the performance of three-phase induction motors. For simplicity of analysis, we are considering a per-phase equivalent circuit of a three-phase induction motor. That means all these parameters are per-phase values. So here the parameters Rs and Xs are the stator winding parameters, stator winding resistance and reactance. Similarly, Xr dash and Rr dash are the rotor winding parameters referred to stator, and Is is the stator current, Ir dash is the rotor current referred to stator, Im is the magnetizing current, V is the applied voltage, E is the rotor induced EMF. All these are per phase parameters. Now we will write the basic equations of induction motor. First of all, we will write the equation for synchronous speed. That is, synchronous speed Ns is equal to 120 F by P. That means this is the speed at which the rotating magnetic field of the induction motor rotates. In order to represent the synchronous speed in radians per second, we have to convert this to radians per second like this. That is, omega ms is equal to 4 pi f by p. Now we will write the equation for slip. Slip S is equal to synchronous speed minus actual speed of rotor whole divided by synchronous speed. By rearranging this equation, we will get omega m is equal to omega ms into 1 minus s. That is equation number 3. Now, for simplicity of analysis, we will redraw this per phase equivalent circuit to a much simpler form. For that, we will neglect the stator impedance drop. That is, drop in the stator impedance, voltage drop in the stator impedance, because as compared to the applied voltage, the stator impedance drop is very small. So we are going to neglect it. By neglecting this, we can shift this towards left. It will be like this. So since stator impedance drop is very less than applied voltage V, the equivalent circuit can be simplified as this. So the winding Xm is, the reactance Xm is shifted towards left. So this makes a much simpler form of the per phase equivalent circuit. Now we will have the analysis. Now consider the simplified per phase equivalent circuit. From this equivalent circuit, we can write the equation for rotor current referred to stator, that is IR dash. Here IR dash is equal to this applied voltage divided by this impedance. Because these two branches are parallel, we can say IR dash is equal to V divided by this impedance, that is Rs plus Rr dash by S plus J Xs plus Xr dash. That is equation number 4. Now the equation for power transferred to rotor, that is air gap power. Here the input power given to stator is not completely transferred to rotor. Some amount of power will be lost in stator, and the remaining power will be transferred to rotor. That the rotor receives the power Pg, that is air gap power, is equal to 3 into IR dash square Rr dash by S. So the air gap power depends on slip, and that is equation number 5. But this air gap, the entire air gap power is not completely converted to mechanical power, but there will be some losses. So we have to consider the rotor copper loss. So rotor copper loss is equal to 3 into IR dash square Rr dash, that is I square R loss. So the air gap, a part of the air gap power will be lost as rotor copper loss, and the remaining power will be converted to mechanical power. The electrical power converted to mechanical power, Pm is equal to Pg minus Pc, air gap power minus rotor copper loss. It is equal to, by substituting equation number 5 and 6, we will get 3 into IR dash square RR dash into 1 minus S by S. That is equation number 7. Now we will write the expression for torque developed by the motor. Torque, the general equation for torque developed by any motor is equal to mechanical power developed by the motor divided by speed of the motor. That is equation number 8. So we have already written the expressions for mechanical power and speed. That is equation number 3 and 7. By substituting those two expressions in equation number 8, we will get torque is equal to 3 by omega ms into IR dash square RR dash by S. That is equation number 9. But we have already written the expression for IR dash in equation number 4. By substituting equation number 4 in equation number 9, we will get the expression for torque. This is the general expression for torque of a 3-phase induction motor. Thank you.